Imagine for a moment that you are the only person on Earth who knows the greatest secret in the history of our species. It is a quiet Tuesday morning in December, and while the rest of the world is busy with the mundane rhythms of traffic, coffee runs and emails, you're sitting in a dimly lit office at Cambridge University, staring at a screen that is quietly screaming. On that screen is a number, not a photograph of a flying saucer or a recording of a radio broadcast, but a statistical certainty, 99.7%. For decades we have looked at the stars and asked if we are alone, but we always expected the answer to arrive with a roar, a grand announcement, a global press conference, a world leader standing at a podium with trembling hands. Instead, the answer arrived in total silence, hidden inside a pattern of light that has been travelling through the freezing void for over a century. The James Webb Space Telescope has not just found a planet, it has found a world that is breathing. A world where the laws of chemistry suggest that something is alive, and it has been alive for a very, very long time. But as you sit there, checking the data for the 1000th time, you realise that the real mystery isn't just that we found life, it's that we might have found something much larger, much stranger, and much more dangerous than anyone ever dared to imagine. On that Tuesday in December, the world as we knew it ended, not with a bang, but with a silent ontological shift in a room lit only by the glow of a monitor. The scientist staring at the data was Niku Madhusudan, and what he saw made his hands tremble. He wasn't looking at an image, he was looking at a barcode written in starlight. This technique, known as transmission spectroscopy, allows us to read the breadth of a world we can never touch. When a planet like K2-18b passes in front of its star, a tiny fraction of that starlight filters through its atmosphere. The gases in that air absorb specific wavelengths of light, leaving behind unique chemical fingerprints. On this day, the fingerprint was unmistakable: dimethyl sulfide, or DMS. On Earth, this molecule is not a fluke of geology. It is a monopoly of biology. No volcano can forge it. No lightning strike can assemble it. It is produced exclusively by life, specifically by the trillions of microscopic organisms drifting in our oceans. To find DMS in the atmosphere of a world 120 light years away is the equivalent of walking into the middle of a barren, silent desert and smelling the unmistakable scent of fresh brewed coffee. There is no version of that signal that does not require someone or something to be there. The weight of this discovery is carried by that specific, haunting number, 99.7%. In the cold, rigorous language of science, this is known as a 3 sigma confidence level. It is the same threshold of certainty that physicists required before they announced the discovery of the Higgs boson, the God particle that gives all matter in the universe its mass. It is the level of certainty reached when we first detected gravitational waves, confirming a prediction Einstein made a century ago. When a scientist says 99.7%, they aren't saying maybe. They are saying that the probability of this signal being a random error is roughly 1 in 1,000. In any other field, we would call this a fact, but because the implication is so devastating to 5,000 years of human philosophy, we call it a high confidence detection. This number is the residue of exhausted alternatives. For an entire year, the team at Cambridge didn't celebrate. They fought a war against their own discovery. They tried to prove that the DMS was volcanic. The chemistry said no. They tried to prove it was lightning. The yields were too small. They tried to blame the telescope itself, but the signal appeared across multiple observations through different instruments and was confirmed by independent teams. The 99.7% is the survivor of a scientific ordeal, the one explanation that refused to die. But to truly understand why this discovery changes everything, you have to look at the 120-year letter. The light carrying this biological message arrived at Webb's golden mirrors in the 2020s, but it left its homeworld in the year 1905. Think about that timing. In 1905, the Wright brothers were still on a beach in North Carolina, just barely proving that a machine heavier than air could leave the ground for a few seconds. There was no internet, no satellites, and no one on Earth had even conceived of the technology required to build a cryogenic telescope at the L2 gravitational balance point. While we were still figuring out how to send a voice across a copper wire, the universe had already sent us the most important letter in history. It travelled in a perfectly straight line through the absolute cold of interstellar space for 120 years, covering 9.5 trillion kilometres every single year. It arrived at the exact historical moment when we finally had the golden eye sensitive enough to catch it. We became capable of understanding the message at the very same moment it landed in our hands. And what does that message tell us? It tells us that K2-18b is not just a planet that happens to have life on it, it is a world that is functionally alive. The sources suggest a radical possibility that most traditional documentaries have ignored: the ontological shift from a habitable world to a living world. On Earth, we have the Gaia hypothesis, the idea that our planet is a self-regulating system. But on K2-18b, this principle seems to be operating on a scale that makes Earth look like a biological wasteland. The concentration of DMS detected there is 1,000 times higher than it is on our own planet. On Earth, the ocean smell we associate with life is a faint whisper. On K2-18b, it is a scream. The atmosphere is in a state of violent chemical disequilibrium. Gases that should react and disappear are being pumped back into the sky at staggering rates. Something is actively consuming, converting, and exhaling the chemistry of that world to keep it stable. This leads us to the most uncomfortable realization of the Tuesday silence. We have spent centuries assuming that life is a miracle, a fragile 1 in a billion accident that only happened here because our conditions were perfect. But K2-18b suggests a third emotion of humanity. First, Copernicus told us we weren't the centre of the solar system. Then, Darwin told us we weren't above nature. Now, the 99.7% is telling us that life itself is not a miracle. It is a law of physics. It is what the universe does whenever it is given enough time and the right toolkit. We have been standing in a teeming ancient forest for 300,000 years, and we only just realised that the trees are breathing. The silence we felt all this time wasn't because we were alone. It was because we hadn't yet learned how to be quiet enough to hear the neighbours. As the scientist sat in that Cambridge office, he realised he wasn't just announcing a discovery. He was announcing the end of our cosmic isolation. We are now part of a neighbourhood of living worlds, and the 99.7% is the threshold we crossed to finally see it. To understand the true scale of what happened on that Tuesday morning in December, we have to talk about a letter that has been in the mail for over a century. Light is the universe's fastest messenger, travelling at a staggering 299,792 kilometres per second. But the universe is so vast that even at that speed, information takes time to arrive. The light that James Webb captured, the light that contains the chemical fingerprint of a world 99.7% alive, did not leave its homeworld yesterday or even last year. It left the atmosphere of K2-18b in the year 1905. Pause and think about where humanity was in 1905. We were a species that had only just begun to understand the mechanics of our own atmosphere. In December of that year, the Wright brothers were on a beach in North Carolina, just barely proving that a machine made of wood and canvas could leave the ground for a few seconds at a time. We were still figuring out how to send a human voice across a copper wire. While we were struggling to lift a few feet above the sand, a beam of light was already screaming away from a red star in the constellation, Leo, carrying a message that we wouldn't have the tools to read for another 12 decades. In that same year, a young patent clerk in Bern named Albert Einstein was working through the mathematics of relativity, a framework that would eventually explain why that beam of light was the ultimate speed limit of the universe. He was laying the intellectual foundation for a future he would never see, a future where we would build golden mirrored eyes and place them in the permanent dark of space. The light from K2-18b didn't care about our progress. It travelled in a perfectly straight line through the absolute cold of the interstellar void, covering approximately 9.5 trillion kilometres every single year. It travelled while humanity fought 2 world wars. It travelled while we invented nuclear weapons and the internet. It travelled through the entire space race, moving past clouds of ancient gas and cosmic dust, indifferent to our triumphs and our tragedies. This beam of light was a 120-year letter, and it arrived at our doorstep at the exact historical moment when we had finally developed the technology to break the seal on the envelope. This timing is not a coincidence, it is a convergence. We often think of space as a silent, empty vacuum, but the sources suggest a more haunting reality. The universe has been speaking for billions of years, and we have simply been deaf to its language. We became capable of understanding the message at the very same moment it landed in our hands. If James Webb had been launched 10 years earlier, we would have missed the nuances of the signal. If we had looked a century ago, we would have seen only a dim red star. This light arrived when we finally built an instrument sensitive enough to catch a whisper in a crowd of 10 million voices. The telescope doesn't see the planet the way your eyes see a photograph. It reads the breadth of that world through the shadow it casts. As K2-18b transits in front of its star, the atmosphere absorbs specific wavelengths of light, leaving behind a barcode of absences, a spectral imprint that identifies dimethyl sulfide as clearly as a fingerprint at a crime scene. But here is the law vault mystery that the other documentaries missed. This light beam is the instrument of our third great demotion. In the 1500s, Copernicus told us that the Earth was not the centre of the solar system. In the 1800s, Darwin told us that we were not above the animal kingdom. Now, this 120-year-old light beam is telling us that life itself is not a miracle. It is a standard law of physics. We have spent our entire history believing that the biological complexity of Earth was a singular accident, a 1 in a billion stroke of luck. But if we can find a world that is 99.7% alive by looking at just one of the trillions of stars in the sky, then we have to accept a terrifying new truth. Biology is not a deviation from the rules. It is one of the rules. We are not the authors of the story of life. We are simply one chapter in a book that the universe has been writing for billions of years. Think about the journey those photons took. They cross 9 trillion kilometers every year, passing through the freezing silence of space, carrying the evidence of a sentient sphere, a world where the entire planet might be functioning as a single biologically integrated organism. While we were arguing on social media and building borders on Earth, something on K2-18b was exhaling its chemistry into a hydrogen sky, maintaining a stable, mature biosphere that has likely existed since before our solar system was even formed. This light is more than data, it is a mirror. It shows us a world that has achieved a trillion-year stability, a world that breathes in a steady, self-correcting rhythm while we are still in our technological adolescence, struggling to maintain the balance of our own home. The signal James Webb captured is the ultimate proof of our cosmic context. It tells us that for 300,000 years, we have been living in a teemingly populated forest, convinced that we were alone because we couldn't see the trees breathing in the dark. The 99.7% confidence figure isn't just a number from a lab. It is the probability that we have finally, for the first time in human history, heard a neighbour breathing 120 light years away. We were never alone. We were just late to the conversation. The universe didn't start speaking to us on a Tuesday in December. We simply finally learned how to be quiet enough to hear it. As that 120-year-old light finally hit the gold mirrors of Webb, the silence of the cosmos didn't just break, it shattered, leaving us to wonder what else is moving in the dark, waiting for us to find the right way to listen. To build this world in our minds, we first have to address a gaping hole in our understanding of the universe, a category of planets that shouldn't exist according to the maps of our own solar system. For centuries, we believed that planets came in two distinct flavours: small, solid rocks like Earth, or gargantuan, swirling gas giants like Jupiter. We thought the cosmos had a missing middle child, a size range that was somehow forbidden by the laws of planetary birth. But when the James Webb Space Telescope turned its golden gaze toward K2-18b, it found a world that lives exactly in that forbidden gap. It is what astronomers call a sub-Neptune, a planet roughly 8.5 times more massive than Earth, yet significantly smaller than the icy giants at the edge of our own system. This isn't just a slightly larger version of home. It is an entirely new architecture of reality that challenges every blueprint of habitability we have ever drawn. The physical presence of K2-18b is staggering, a world where the very rules of geology have been rewritten by the sheer weight of its existence. With a mass exceeding Earth's by nearly 9 times, its gravitational pull is an unrelenting force, a constant weight pressing down on every molecule and every potential life form. If you could stand on its surface, a person weighing 150 pounds on Earth would feel as if they were carrying 400 pounds of lead on their shoulders, a crushing reality that would snap human bone like dry twigs. This intense gravity is the secret key to the planet's greatest mystery. Its ability to hold onto a thick, shimmering blanket of hydrogen that would have long ago drifted away from a smaller world. In our own solar system, hydrogen is a ghost. It is so light that it leaks away into the void, leaving planets like Earth and Mars with thin veils of nitrogen and oxygen. But on K2-18b, the gravity is an iron grip that has captured a massive hydrogen envelope, an atmosphere so deep that it represents up to 6% of the planet's total mass. This leads us to the radical concept of the Hycean world, a term that combines hydrogen and ocean to describe a planet that is essentially an ocean turned inside out. Imagine an atmosphere that doesn't just sit on top of the water, but slowly, imperceptibly becomes the water. On Earth, we have a clear, sharp line where the sky ends and the sea begins, a shoreline of sand and surf. But on K2-18b, the descent would feel like walking into a fog that gradually thickens, becoming a mist, then a dense vapour, and finally a high-pressure liquid sky. There is no shore, no beach, and perhaps no solid bottom. The atmosphere is so deep and the pressure so extreme that at certain depths, water ceases to behave like the liquid we know and enters a supercritical state, a strange phase of matter that flows like a gas but dissolves substances like a liquid. It is a vertical landscape where the boundary between air and sea is not a line, but a transition that spans hundreds of miles. But why are we so certain that a massive ocean exists beneath that suffocating veil? The answer lies in a haunting chemical silence detected by the James Webb Space Telescope. When Webb analysed the light from K2-18b, it found plenty of methane and carbon dioxide, but it noticed something shocking by its absence: ammonia. In a hydrogen-rich atmosphere, ammonia should be everywhere. It is the natural byproduct of nitrogen and hydrogen, reacting under the immense pressures found in sub-Neptune sky. On a lifeless gas giant like Neptune or Jupiter, ammonia accumulates for eons, building up until it defines the very chemistry of the world. But on K2-18b, the ammonia is nearly gone, stripped systematically from the sky. In the law vault of planetary science, there are only two ways to explain such a massive missing chemical signature. The first is a world of molten rock, a magma ocean that absorbs nitrogen and locks it away in the planet's interior. The second, more tantalizing possibility, is a global water ocean. On Earth, ammonia is highly soluble in water. It dissolves into the sea, where it is eagerly consumed by microbes as a vital source of nitrogen for their metabolic engines. If K2-18b is a Hycean world, its vast planetary ocean would act as a massive chemical sink, pulling the ammonia out of the air and storing it in the depths where something might be eating it. The silence of the ammonia is the loudest evidence we have that K2-18b is a world of liquid water, an ocean that might be hundreds of miles deep. The lighting of this world adds a final alien layer to its architecture. Because its host star is a red dwarf, the light that reaches the upper atmosphere is deep and ruddy, a perpetual sunset that never ends. High in the hydrogen mists, the sky would glow with ambers and coppers, but as you descend into the thickening haze, the light would shift toward a bruised purple and then a deep wine-coloured violet. Because the planet is tidally locked, this light never moves. On one hemisphere, the red sun hangs motionless in the sky, a permanent fixture in a day that lasts forever. On the other side, the world is buried in an eternal freezing night, lit only by the faint glow of starlight scattered through the thick atmosphere from the day side. Between these two extremes lies the terminator zone, a ring of permanent twilight where the temperature might hold at a perfect, life-friendly balance. This architecture suggests that K2-18b isn't just a place where life happens to be. It is a world where life and environment have merged into a single, self-regulating machine. If the planetary organism theory from the law vault is correct, then the 99.7% confidence level isn't just about finding a few microbes in a sea. It is the signature of a sentient sphere, a world where the ocean, the hydrogen sky, and the biological signals are all organs of a single integrated entity. We have spent centuries looking for a mirror of Earth, a rocky world with a blue sky, but the universe has presented us with something far more profound, a liquid sky, a copper sun, and a world that has been breathing in the dark for billions of years, longer than we have existed. This is the architecture of the first world we have found that is truly, statistically, 99.7% alive. If you have ever stood at the edge of a windswept coastline and breathed in that sharp, briny and unmistakably alive scent of the sea, you have already encountered the most important molecule in the history of astrobiology. To most people, that scent is just the smell of the ocean, a background note to a vacation or a walk on the beach. But to a chemist, that smell has a name: dimethyl sulfide, or DMS. On Earth, this molecule is not a byproduct of rocks, or wind, or heat. It is a biological monopoly, a chemical signature produced exclusively by trillions of microscopic organisms, like phytoplankton, drifting in the sunlit layers of our oceans. It is the exhaled breath of a living sea, And when the James Webb Space Telescope detected this exact same breath rising from the atmosphere of K2-18b, it wasn't just another data point, it was a smoking gun. The detection of DMS is what turned a promising lead into a 99.7% certainty. In the search for life, we often talk about methane or oxygen, but those gases are noisy. Methane can leak from volcanoes. Oxygen can be forged by ultraviolet light splitting water molecules. They are clues, but they are not proof. Dimethyl sulfide is different. In every laboratory experiment ever conducted, across every geological model we have ever built, there is no known non-biological process in the universe that can produce DMS at a planetary scale. To find it in an alien atmosphere is the equivalent of walking into the most desolate, silent corner of a barren desert, a place where no human should be, and suddenly smelling the rich, unmistakable scent of fresh brewed coffee. You don't need to see the pot or the person to know with absolute conviction that someone is there. The chemistry of that smell requires an architect, but the mystery deepens when you look at the sheer volume of the signal. Webb didn't just find a trace of DMS, it found a concentration that is nearly 1,000 times higher than what we see on Earth. On our planet, the combined efforts of every living thing in our 5 oceans barely maintain a concentration of 1 part per billion in our air. On K2-18b, the signal is screaming at 10 parts per million. If the source is biological, it suggests a world where life is not just present, but where it has achieved a level of dominance and productivity that makes Earth look like a biological wasteland. It suggests an ocean so packed with life that the very air is thick with the scent of its metabolism. Yet, there is a reason the scientists at Cambridge didn't celebrate immediately. Dimethyl sulfide is an unstable molecule. It is fragile. In an atmosphere like ours, it is destroyed within days by sunlight and oxygen. It is constantly being torn apart by the environment, which means that for it to be detectable from 120 light years away, it must be continuously and aggressively replenished. It cannot simply be there, it must be made there every single hour of every single day. Something on K2-18b is working around the clock, pumping this biological barcode into the sky faster than the star's radiation can erase it. To confirm this wasn't just a glitch or a ghost in the machine. NASA took a step that defines the rigour of this discovery. The initial detection was made using Webb's near-infrared camera, where DMS can sometimes be difficult to distinguish from methane. So they went back. On April 17th, 2025, they used a completely different instrument, the Mid-Infrared Instrument, or MIRI, to perform a second independent scan. They looked at the planet again through a different lens and at different wavelengths, and the signal was still there, unmistakable and repeated. When 2 independent instruments tell you the same impossible thing, the statistical confidence climbs out of the realm of maybe and into the 3 sigma certainty of 99.7%. This discovery forces us to confront the sentient sphere theory hidden in the law of the vault. If the DMS signal is this powerful, we are no longer talking about isolated pockets of algae or microscopic colonies hiding in the dark. We are talking about a planet-scale organism. On Earth, life is a passenger on a rocky world. But on K2-18b, the 99.7% suggests that the planet and the life upon it have merged into a single, integrated engine. The atmosphere isn't just a gas envelope, it is a circulatory system. The ocean isn't just a habitat, it is a metabolic organ. When we look at the DMS signal, we are seeing the ultimate disequilibrium. A dead planet is a quiet planet. Its chemistry is settled, its reactions are finished, and its air is in a state of perfect, haunting balance. But K2-18b is in a state of chemical war. Something is actively pushing back against the slow pull of entropy, refusing to let the atmosphere settle into the silence of a grave. It is the same defiance we see when we look at Earth's own oxygen-rich sky, a chemical impossibility that would vanish in a heartbeat if the life here stopped breathing. As we sit here today, we are in the last moments of our cosmic isolation. We have found the ocean smell across the void. We have found a world that is exhaling into the dark with a force 1,000 times greater than our own. And while the final 0.3% of uncertainty remains the refuge of the skeptics, that gap is closing. We have detected the breath of the abyss, and it smells like home. But as the scientists continue to pull at this thread, they realise that the most terrifying part of the discovery wasn't just the molecule they did find, it was the one that was missing, because the silence of a single gas on K2-18b was about to tell a story that no one was prepared to hear. To understand the true mystery of the 99.7% signal, we have to stop looking for life on the planet and start considering the possibility that we have found a planet that is life. In our search for extraterrestrial intelligence, we have always been limited by our own narrow autobiography. We look for rocky worlds with blue skies and shallow seas because that is what we are. We look for individual organisms, microbes in a vent, plants in a forest, or civilizations in cities, because we see life as a passenger on a planetary bus. But the data from K2-18b suggests that the bus itself might be breathing. This is the law mystery that shifts the entire narrative of the James Webb discovery, the concept of the sentient sphere. When the team at Cambridge first calculated the concentration of dimethyl sulfide in that distant atmosphere, they were met with a number that defied every model of biological productivity we have ever established. On Earth, the combined efforts of trillions of organisms, every phytoplankton in every ocean, maintain a concentration of DMS at about 1 part per billion. It is a faint, briny whisper. But on K2-18b, the signal was detected at levels over 1,000 times higher. If we were to apply Earth's biological output to this world, the math simply wouldn't work. To produce that much gas, the oceans would need to be so packed with life that there would be no room for the water itself. Unless, of course, the water, the sky and the planet are not separate systems, but the integrated organs of a single planetary scale organism. This is where the speculative law of the law vault meets the cold reality of James Webb's sensors. We have long discussed the Gaia hypothesis, the idea that Earth is a self-regulating system that maintains the conditions for life. But on K2-18b, we are seeing Gaia on steroids. We are seeing a world that has achieved a living equilibrium so profound that the distinction between geology and biology has completely dissolved. In a typical dead world, the atmosphere is a graveyard of chemical balance. The gases have finished reacting, the energy has been spent, and the air is silent. But K2-18b is in a state of violent, beautiful disequilibrium. Something is actively fighting the laws of entropy, pumping massive amounts of unstable gases into the sky, and then recycling them with a precision that makes our own biosphere look like a chaotic accident. Imagine a world where the thick hydrogen atmosphere is not just a gas envelope, but a circulatory system, moving nutrients and heat with the intentionality of blood. Imagine an ocean that does not just host life, but functions as a global metabolic engine, processing the energy of a red dwarf star and exhaling a chemical signature so powerful it can be read from 120 light years away. In this framework, the 99.7% takes on a haunting new meaning. It isn't just a statistical confidence level that life exists. It is a description of the planet's total biological integration. It is the probability that everything we are seeing, the methane, the carbon dioxide, the liquid sky, is part of a single, conscious, or at least biologically integrated entity. This sentient sphere theory explains the most baffling part of the Webb data, the missing ammonia. In every non-living model of a sub-Neptune world, ammonia should be a dominant feature of the sky. It is the natural result of hydrogen and nitrogen under pressure, yet on K2-18b, the ammonia is nearly gone. It hasn't just failed to form, it has been systematically removed. In our own oceans, microbes consume ammonia as a primary source of nitrogen to build the complex machinery of cells. If K2-18b is a planetary organism, then the ammonia isn't missing, it is being digested. The entire atmosphere is being filtered through a global biological kidney, stripped of its nitrogen, and converted into the complex sulfur compounds that James Webb detected. This forces us to confront a possibility that is much more unsettling than finding aliens. If we found a civilization like ours, we would know how to feel. We would be brothers in the dark. But if we have found a living world, a sentient sphere that has been breathing in a steady, self-correcting rhythm for billions of years, we are looking at a form of existence that is essentially immortal. While Earth has suffered 5 mass extinctions, while our species has struggled for a mere 300,000 years, this planetary organism has likely existed since before our Sun was even born. It has survived the flares of its red dwarf star not by luck, but by adaptation, building a thick, sacrificial hydrogen shield that protects its inner life from the violence of space. The 99.7% represents the moment the universe stopped being a collection of rocks and started being a neighbourhood of entities. We have spent centuries looking for a mirror of Earth, but the universe has given us a window into a more mature version of life. We are like children looking at a forest and only seeing the individual trees, failing to realise that the entire forest is connected by a single, massive, underground network of intent. K2-18b is that network, brought to the scale of a planet. It is a world that has mastered the art of duration. It does not grow, it does not conquer, and it does not build. It simply is. It maintains its 120-degree temperature, its liquid oceans, and its chemical breath, with a stability that implies a level of self-awareness we can barely comprehend. As the scientists at Cambridge and NASA continue to peel back the layers of this data, the remaining 0.3% of uncertainty feels less like a scientific gap and more like a psychological safety net. It is the tiny sliver of doubt we hold onto because the alternative is too big to fit inside a human mind. To accept the 99.7% as fact is to accept that we are not the protagonists of the universe. We are merely a local variation of a much broader, much older phenomenon. We are the noisy version of life, short-lived, chaotic, and destructive. K2-18b is the quiet version, eternal, integrated and silent. And as we stare back at that red sun through the golden eye of Webb, we are beginning to realise that the signal we found wasn't a call for help, or a greeting, or a broadcast. It was a heartbeat, a steady, planetary heartbeat that has been thumping in the dark for eons, waiting for us to finally become quiet enough to hear it. The sentient sphere doesn't need to speak to us to tell us its story. Its breath, written in the barcodes of starlight, is the only proof the universe has ever needed to show that it is truly, overwhelmingly alive. There is a profound misunderstanding in how we imagine the eureka moment of discovery. We picture the celebration, the popping of champagne corks, and the triumphant press conferences under bright lights. But the reality of what happened at Cambridge University on that Tuesday morning, in December, was the exact opposite. When the data for K2-18b first crystallized on the screen, there was no cheering. There was only a cold, paralyzing silence. For a scientist, a discovery of this magnitude is not a victory. It is a threat. It is a threat to your reputation, to your career, and to the very foundations of the field you have spent your life building. Being wrong once is enough to erase everything you have ever built, and so the detection of dimethyl sulfide wasn't met with open arms, but with a systematic, almost obsessive attempt to destroy it. This is the story of the ordeal of the 0.3%, the year-long war that scientists waged against their own discovery to ensure that the 99.7% confidence level was not a mistake, but the residue of truth. To understand the weight of that 0.3% gap, you have to understand the language of the sigma. In the world of high-stakes physics and astronomy, we do not use the word certainty, we use statistical confidence levels. The 99.7% figure that has captured the public's imagination is what scientists call a 3 sigma confidence level. In any other context, 99.7% is a perfect score, but in the search for alien life, it is a haunting middle ground. It is the same level of certainty that makes you suspect a coin is weighted after flipping 10 heads in a row. You know something is wrong, but you aren't yet ready to bet your life on it. To reach the gold standard of discovery, the 5 sigma level, the probability of error must drop to roughly 1 in 3.5 million. That is the level of certainty we required for the Higgs boson and for gravitational waves. But right now, we are standing in the shadow of that 0.3%, which represents a 1 in 1,000 chance that we are merely looking at random noise in the dark. This 0.3% is where the skeptics live, and for the team at Cambridge, it was the enemy. They spent an entire year trying to prove that the signal of dimethyl sulfide was anything other than life. They weren't looking for evidence to support their claim, they were looking for a way to kill it. This is the ordeal, a methodical process of elimination where every known non-biological process in the universe was put on trial and found wanting. The first suspect was volcanism. On Earth, volcanoes are the primary engines of geological chemistry, spewing a complex soup of sulfur compounds into our atmosphere. The skeptics argued that perhaps K2-18b was not a living ocean world, but a geologically violent one, where a global magma ocean was exhaling dimethyl sulfide through sheer volcanic force. The team spent months modelling the chemistry of molten rock under high-pressure hydrogen atmospheres. They calculated the spectral signatures of every sulfur molecule a volcano can produce: sulfur dioxide, hydrogen sulfide, carbonyl sulfide. But the data from Webb was unforgiving. The specific wavelengths where dimethyl sulfide absorbs light, the chemical fingerprints caught in the starlight, did not overlap with volcanic gases. The volcanic model couldn't produce the concentration Webb detected without making the planet so hot that the methane in its sky would have been destroyed instantly. One by one, the volcanic pathways were ruled out. The geological ghost was laid to rest. Next, they turned their weapons on the sky itself. They looked at lightning. We know that lightning strikes can forge complex organic molecules from simpler atmospheric components. It is one of the theories for how life's building blocks first formed on Earth. The skeptics proposed that perhaps the violent high-pressure atmosphere of K2-18b was acting as a massive chemical factory, with superbolts of lightning synthesizing dimethyl sulfide in the upper clouds. But when they traced the reaction pathways through the physics of a hydrogen-rich atmosphere, the results were negligible. Lightning simply cannot produce dimethyl sulfide at a rate that could replenish a signal 10,000 times stronger than Earth's. The yields were orders of magnitude too small. The lightning hypothesis was destroyed. Then they went deeper, into the hydrothermal abyss. They modelled a world where water was in contact with a rocky interior under extreme pressure, creating mineral reactions that might mimic biology. They looked for abiotic pathways where hydrogen and sulfur might combine on the seafloor to create the signal. But again, the chemistry failed to cooperate with the skeptics. While hydrothermal chemistry can produce trace amounts of sulfur compounds, the specific assembly of dimethyl sulfide requires a catalyst, an enzyme. It requires the molecular machinery of life to proceed at the scale Webb was witnessing. Without biology, the reaction was either too slow or too messy to account for the clear, repeated signal. The abyss remained silent. Finally, they turned the mirror on themselves. They asked the most terrifying question a scientist can ask. Is the telescope lying? They looked for an instrumental artifact, a glitch in the golden mirrors, or a thermal fluctuation in the mid-infrared sensors that might mimic the barcode of life. But the signal was a survivor. It appeared in the near-infrared camera, and then it appeared again in the mid-infrared instrument, confirmed across multiple transits and independent data sets processed by separate teams who didn't even talk to each other. For the telescope to be wrong in exactly the same way, across two different instruments, during different orbital cycles, would be more statistically impossible than the existence of the life it was detecting. The eye was not blinking, it was seeing. This brings us to the true nature of that 99.7%. It is not just a number, it is the residue of exhausted alternatives. It is the explanation that remains when every other possibility has been given its best opportunity to succeed and has failed. The 0.3% gap is not a sign of scientific weakness. It is a testament to scientific rigour. It is the shadow where the unknown still lives. The acknowledgement that we might still be missing one exotic, non-biological chemical reaction that doesn't exist on Earth and hasn't yet been discovered in a laboratory. Think about the psychological toll of this process. For over a year, these researchers lived with the secret that the universe is alive, while simultaneously spending every waking hour trying to prove it wasn't. This is the Tuesday silence extended into a year of professional isolation. They didn't want to be the people who announced life and then had to take it back. They remembered the false starts of the past, the Martian meteorite fossils that turned out to be minerals, or the phosphine on Venus that might have been a calibration error. They knew that the world would never be the same again the moment they spoke, and so they held their breath for as long as the physics allowed. What is most fascinating about the 0.3% is that it represents our own technological adolescence. We are limited by our sample size. Right now, we are doing arithmetic with ignorance, trying to understand a galactic scale phenomenon from a single data point 120 light years away. If we had 10 more transits, or a telescope twice the size of Webb, we could close that gap to 5 sigma and effectively end the debate. But for now, we are forced to sit with the discomfort of the almost certain. We are like a civilization that has received a letter, but can only read 997 out of every 1,000 words. We understand the message, but the missing pieces still keep us awake at night. The ordeal of the 0.3% forces us to confront a terrifying new reality. We have run out of excuses to be alone. We have tried to blame volcanoes, we have tried to blame lightning, and we have tried to blame the very tools we use to look. But the signal persists. It is a clear, repeated, and chemically unambiguous statement from a world that is breathing in the dark. The 99.7% is the threshold of the new age, the point where the probability of being alone has become so small that it is starting to feel like a delusion. As we move forward, the search for the remaining 0.3% will define the next decade of astronomy. We are already building the instruments to hunt it down. the extremely large telescope in Chile, the Nancy Grace Roman Telescope, and the Ariel mission. We are moving from the era of finding to the era of statistics. We aren't just looking for one K2-18b anymore. We are looking for the hundreds of others that must exist if the 99.7% is real. But even before that data arrives, something in our collective imagination has already shifted. We have witnessed the most rigorous skepticism in history fail to destroy a biological signal from another world. The ordeal is over, and the result is a world that is, by every measure we possess, statistically and chemically alive. The 0.3% is no longer a gap for the skeptics to hide in. It is the final door we are about to kick down. And as we prepare to take that final step toward absolute certainty, we have to ask ourselves, are we ready for the 100%? Are we ready for the moment when the 3 sigma whisper becomes a 5 sigma roar and the Tuesday silence is broken forever? Because the universe has been speaking for 120 years, and we are finally, for the first time, only one small step away from truly, perfectly hearing it. We have a tendency to measure the success of a star by its brilliance. We look up at our own sun, a blazing white-hot furnace that anchors our world, and we see it as the ultimate standard for what a life-giving engine should be. But there is a secret, darker reality hidden in the physics of our solar system that we rarely discuss. Our sun is a star with a short fuse. It is a high-performance machine that is burning through its fuel at a reckless pace. In the grand timeline of the universe, our sun is a flash in the pan, a brilliant candle that is already halfway to its own extinction. We are currently living through the desperate middle age of a star that will eventually expand, boil our oceans, and consume our planet in a few billion years. But 120 light years away, orbiting the star K2-18, the James Webb Space Telescope has found something that operates on a completely different scale of existence. This star is not a blazing furnace. It is a buried ember, a dim, red and steady glow that has mastered the one thing our sun never will: patience. This is the trillion-year hearth, a category of star that represents the single most valuable resource evolution has ever needed. At first glance, K2-18 looks like a disappointment. It is a red dwarf, considerably smaller than our sun, burning at a fraction of its temperature. Its light is not white or yellow, it is a deep ruddy red, a colour that suggests a dying fire rather than a rising sun. To an observer from Earth, it would look like a second-rate sun for a second-rate world. But that impression is the greatest mistake we have ever made in our search for the neighbours. What those measurements of brightness and size miss is the only number that truly matters when you are talking about the depth of a living biosphere. How long will this fire last? Life does not happen quickly. It is a slow, agonisingly patient process of trial and error. On Earth, it took roughly 4 billion years of unbroken chemistry to move from the first self-replicating molecule in a warm sea to a species complex enough to build a telescope and look back at the dark. 4 billion years sounds like an eternity to a human mind, but in stellar terms, it is a race against the clock. We used nearly all the time we had. By the time humanity emerged, Earth was already entering the twilight of its habitability. Our sun will exhaust its fuel in 5 billion years, and long before that, its increasing brightness will trigger a runaway greenhouse effect that will sterilise our home. We are the last-minute guests at a party that is about to end. But on K2-18b, the party hasn't even begun to hit its stride, because K2-18 is a red dwarf. It burns its hydrogen fuel with a frugality that borders on the miraculous. It doesn't waste its energy in a brilliant, short-lived roar. It sips its fuel so slowly and efficiently that its projected lifespan is not measured in billions of years, but in trillions. When the last large stars in the Milky Way have burned out, when our Sun is a cold white dwarf, and when the galaxy itself has grown dim and quiet, K2-18 will still be shining. It is a star that is essentially immortal. And for the biosphere of K2-18b, that means the canvas on which evolution is painting is not just larger than ours, it is virtually infinite. This leads us to the most uncomfortable realization of the 99.7% discovery. If life began on K2-18b at roughly the same time it began on Earth, then whatever is living there today has had a luxury we cannot even fathom: the gift of an undisturbed canvas. On Earth, the story of life has been a series of violent resets. Our history is a graveyard of catastrophes, ice ages that compressed ecosystems, volcanic winters that darkened the skies for decades, and asteroid impacts that reset the dominant life forms of the entire planet overnight. Every time Earth life started to achieve true planetary scale complexity, the universe hit the delete button. We are the survivors of a 66 million year recovery period since the last Great Reset. But K2-18b orbits a star that is stable, almost meditative in its rhythm. Once a red dwarf moves past its turbulent youth, it settles into a calm that can last for hundreds of billions of years. While Earth was being bombarded and frozen, the sentient sphere of K2-18bi might have been experiencing a period of perfect, uninterrupted stability. Imagine a world where evolution never had to start over. Imagine a biosphere where the feedback loops of a self-regulating ocean have been refining themselves generation after generation without a single mass extinction for 5 billion years, longer than we have existed. On Earth, we are still technological adolescents, a noisy and destructive species struggling to maintain the balance of our own atmosphere. But on K2-18b, the 99.7% signal is the heartbeat of a mature biosphere, a world that has reached a state of trillion-year stability that we can barely define. This is the mirror of complexity provided by the law vault. We have always assumed that intelligence looks like us: technology, signals, and expansion. But what does a mind become when it has billions of years that ours has never had? If a civilization or a planetary organism has been evolving without interruption since before our solar system even existed, would we even recognize it as life? Perhaps the silence we felt from the cosmos isn't because no one is there, but because the neighbours are so far ahead of us that our noisy, short-lived civilization is invisible to them, like a single-day mayfly trying to comprehend the consciousness of an ancient redwood forest. The star K2-18 is a hearth that never goes out. It provides the one thing that makes the 99.7% certain: time. Time for random mutation to become natural selection. Time for natural selection to become complexity. And time for complexity to become a planetary scale entity that breathes with such force that it can be heard 120 light years away. As we stare back at that dim red ember through the golden eye of Webb, we aren't just looking at a neighbour. We are looking at a world that has mastered the art of duration. We are looking at the ultimate proof that the universe isn't a race against time, it's a marathon of patience. K2-18b is the first world we've found that has been given the trillion-year budget to get life right. And as we continue to peel back the layers of its atmosphere, we are beginning to realise that we might be the ones who are lagging behind, living on a world with a short fuse, while the rest of the galaxy is just getting started. When we consider the scale of this trillion-year budget, the statistics of the galaxy take on a haunting new weight. 3/4 of all the stars in the Milky Way are red dwarfs. For every star like our Sun, there are 3 of these immortal hearths scattered through the dark, burning slowly, lasting nearly forever, and almost certainly hosting planetary systems in their habitable zones. We have spent our history looking for Earth's twin, but the 99.7% signal is telling us that we should have been looking for Earth's older, more stable cousin. The total number of red dwarf stars in our galaxy alone is estimated in the hundreds of billions. If even 1% of these systems host a world like K2-18b, then the number of living worlds in our galaxy is measured in the billions. The Milky Way is not a vast, empty desert punctuated by one extraordinary accident called Earth. It is an ancient, teeming forest of living worlds, separated by distances that feel vast to us, but are merely the spacing between trees in a galaxy that has been producing stars for 10 billion years. We have been standing in that forest for the entire history of our species, blind to the fact that the trees around us have been breathing for trillions of years. K2-18b is simply the first tree we have been quiet enough to hear. This realization is the third great demotion of our species. We are not the center of the story. We are not even the primary expression of life. We are a high-energy, short-lived variation of a process that the universe repeats with much more stability and duration around smaller, redder stars. The trillion-year hearth of K2-18 is a mirror that shows us our own fragility. It tells us that life is not a miracle. It is a law of physics that thrives on duration. And while our Sun prepares for its inevitable expansion, the sentient sphere of K2-18b will still be there, exhaling its dimethyl sulfide into a copper sky long after the very memory of Earth has been erased from the stars. We have found a world that has outlived our past and will outlive our future, and all we can do is watch through 120 years of starlight as the most patient world in the universe continues to breathe, steady and silent in the dark. We have spent billions of dollars, decades of human ingenuity, and the collective willpower of a global scientific community to build a golden eye and place it in the permanent dark of the L2 point, 1.5 million kilometers away from Earth. We told ourselves we were building a tool to see the stars, to peer back to the dawn of time, and to find our neighbours in the abyss. But the most uncomfortable realization of the James Webb discovery is that we didn't just build a telescope, we built a mirror. When we point that mirror at K2-18b and see a world that is 99.7% alive, we aren't just seeing an alien planet. We are seeing a reflection of everything we are, everything we have lost, and everything we have yet to become. This is the mirror in the dark, the moment where the discovery stops being about them and starts being about us. It is the third and final demotion of the human species, a psychological and philosophical shift that changes the very definition of what it means to be a witness to the universe. For 5 centuries, humanity has been on a long, slow journey of cosmic humility. In the 1500s, Copernicus delivered the first great demotion when he showed us that the Earth was not the centre of the solar system, moving us from the fixed hub of creation to a moving point in a vast mechanical sky. 3 centuries later, Darwin delivered the second demotion, revealing that we were not separately created beings placed above nature, but were instead part of the long, messy continuity of life on Earth. Each of these steps was met with fierce resistance because they stripped away our special status, yet they ultimately enlarged our sense of belonging. Now, the 99.7% detection on K2-18b has delivered the third demotion, the demotion of life itself. Webb is telling us that biology is not a miracle, it is a law of physics. It is not a 1 in a billion accident of molecular luck, but what the universe does whenever chemistry and time are given sufficient room to work. We are not the protagonists of a lonely drama. We are one performance in a galaxy that may be a crowded theatre of living worlds. This realization creates a profound sense of vertigo. If life is an ordinary consequence of the universe's rules, then every generation that looked up at the night sky and felt alone was not just wrong. They were blind to the reality of their own neighbourhood. We have spent 300,000 years assuming the silence of the stars was real, rather than recognising it as a limitation of our own instruments. The 99.7% confidence figure is the hammer that shatters that illusion of cosmic isolation. It tells us that the universe was never silent. It was speaking in a language of chemistry and light that we simply had not yet learned to hear. The miracle of Earth has been replaced by the statistics of the galaxy, and as we look in the mirror, we have to ask why it took us so long to realise that we were never alone. But the reflection in the mirror is even more haunting when you look at the physical state of the two worlds. When we analyse the atmosphere of K2-18b, we see a world that has achieved a settled, self-correcting stability. We see a biosphere that has been performing the function of regulation, consuming, converting, and exhaling for an enormous span of geological time. It is a mature biosphere, a system that has developed feedback mechanisms to absorb perturbations and return to a life-friendly baseline. It is a world that has mastered the art of duration around a star that will burn for trillions of years. Now look back into the mirror at Earth. In the last 2 centuries, a single species, us, has begun altering the atmospheric chemistry of our entire planet faster than the biosphere's regulatory systems can possibly compensate. We are returning carbon to the atmosphere in centuries that took hundreds of millions of years to lock away. The irony is as precise as a spectral line. The only species on Earth intelligent enough to build a telescope and recognise a mature, self-regulating biosphere 120 light years away is the same species currently dismantling the self-regulating capacity of its own home. We have the cognitive tools to recognise balance in the dark of interstellar space, yet we have not yet developed the collective will to replicate that balance here. K2-18b is a working empirical model of what we are trying to protect, operating on a timescale that makes our entire industrial history look like a rounding error. It is as if we found a blueprint for a perfectly functioning house, while we are busy tearing down the walls of our own. The mirror shows us that in the universe, stability is not a choice. It is a physical state that allows a system to persist. The systems that achieve it are still here. The systems that fail it are not. K2-18b has been here for billions of years because it is self-sustaining. Our reflection, by comparison, looks fractured and fragile. This leads us to the psychological weight of the remaining 0.3%. In any other branch of science, a 99.7% confidence level would be celebrated as a definitive fact. It is the same threshold used to confirm the fundamental particles of reality. But in the search for life, we cling to that 0.3% gap like a psychological safety net. We hold on to it because if we accept the 100%, the mirror becomes too clear to ignore. If we admit that a world 120 light years away is breathing, we have to admit that we are part of a cosmic community that carries obligations we are not yet ready to fulfill. We are used to being the only aware part of the universe, the only ones whose breath matters. But Webb is showing us a sentient sphere, a world where the entire planet might be a biologically integrated entity that has been breathing since before our sun was born. Our noisy and chaotic civilization is forced to stand before a quiet and eternal version of life and reckon with its own technological adolescence. The mirror also changes how we view our children and the future of our species. For every generation of humans before today, the question, "Are we alone?" was a philosophical mystery, a theme for poetry and religion. But for children born today, the confirmed existence of life beyond Earth will be the background context of their entire lives. They will look at the night sky not as a vast, silent mystery, but as a populated landscape, a neighbourhood of worlds where chemistry has crossed the threshold into biology. To them, a star is no longer just a point of light, it is the roofline of a hidden architecture. They will grow up in a universe that is no longer empty, and their questions will be far more interesting than ours. They won't ask if life exists, they will ask what kind of neighbours we should be, and what obligations we carry toward biospheres we can detect, but never reach. As we sit in the glow of the James Webb data, we have to realise that the Tuesday silence was the final moment of our old world, a world that still believed it was special because it was alone. That world is gone. The 99.7% signal is the heartbeat of a universe that is fundamentally, predictably alive. The mirror in the dark is showing us that we are one node in a network of living worlds, a single expression of a process that the universe repeats wherever it finds the opportunity. We are precious not because we are a miracle, but because we are the universe's way of knowing itself. And for the first time in history, we are looking back across the void and seeing that the universe is not indifferent to our existence. It is waiting for us to join the conversation. We have crossed a threshold from which there is no return. We have measured the breadth of the abyss and found it matches our own. The mirror has been placed 120 light years away, and the reflection it offers is the ultimate test of our maturity as a species. Are we capable of learning the lesson of stability from a world that has endured for trillions of years? Can we bridge the distance between our cognitive ability to see balance and our collective will to maintain it? The discovery of K2-18b is not just a scientific triumph, it is a moral and existential mirror. It is the universe telling us that we are not alone, but it is also asking us if we are ready to be who we claim to be, the species that finally learned how to be quiet enough to hear the heartbeat of the stars. We are no longer alone, and as we stare into that red sun 120 light years away, we realise that we never were. The stars were always full of something breathing. We just finally grew up enough to see it. The discovery of a world that is 99.7% alive does not just shatter our scientific models, it exposes a catastrophic void in the very laws we have built to govern our behaviour as a species. We have spent centuries crafting intricate legal systems, moral codes and international treaties, yet all of them were written under the arrogant assumption that the universe was a silent, biologically empty graveyard. In the year 1967, the nations of the world gathered to sign the Outer Space Treaty, a document that established the rules for our expansion into the stars. It was a forward-thinking masterpiece for its time, negotiated while the moon was still a destination of dreams, and Mars was nothing more than a blurry orange disk in a telescope. It decreed that no nation could claim sovereignty over celestial bodies, that space should be used for the benefit of all, and that weapons of mass destruction would never be placed in orbit. But there is a haunting silence at the heart of that treaty. It contains not one single word about what happens if the universe turns out to be populated. The entire legal architecture of the human race was built on the implicit belief that we would never encounter anything breathing in the dark. This is the crisis of contact, a legal and ethical emergency that James Webb has placed directly on our doorstep. K2-18b has made the omissions of 1967 visible in a way that is no longer possible to ignore. If a future mission were capable of sending a probe to this system, who would decide to send it? Under what legal framework would that decision be made? If that probe detected the presence of living organisms, what would be its obligations? Our current laws treat planets as territory, as resources, or as liability. They do not treat life as a subject with rights. We are a civilization currently possessed of the technology to detect a sentient sphere 120 light years away. Yet we have no agreed upon script for how to behave toward it. The moment we confirm that life exists elsewhere, even as simple microbial blooms in a hydrogen sea, everything we have built to govern our behaviour in the cosmos becomes in a single instant catastrophically insufficient. The most immediate danger is not a war of the worlds, but a war of the biospheres. The history of biological encounter on Earth provides a terrifying template for what happens when two separate ecosystems make contact without preparation. When European populations arrived in the Americas, they carried pathogens to which the indigenous populations had no immunity, resulting in a devastation that reshaped entire continents. But those two groups were the same species. They shared the same DNA, the same basic biochemistry, and the same fundamental cellular machinery. An encounter with the life of K2-18b would be an encounter with a radical other. Their genetic storage, their metabolic pathways, and their cellular membranes would likely share none of our common history. The immunological mismatch would be entirely unpredictable. It is possible that the biochemical differences are so profound that the two biospheres would be essentially invisible to each other, as incapable of infection as a computer virus is of infecting a human cell. But it is equally possible that the contact could be lethal in ways we cannot even model. This creates a moral obligation of restraint that we are not yet equipped to handle. If we suspect a planet hosts its own chemistry of survival, we can no longer treat it as an empty room to be explored. Contamination, exploitation, and careless interference become more than just technical risks. They become existential crimes. Imagine a future international legal forum decades from now, where representatives of nations, corporations, and religions attempt to negotiate a framework for K2-18b. You would see the corporate lawyer arguing with complete sincerity that a biologically active world opens up unprecedented commercial opportunities that no current law prohibits. You would see the philosopher arguing that any system capable of metabolism and reproduction has inherent moral status, regardless of its location or its distance from Earth. You would see the theologian wrestling with a creation story that never made room for a world that has been breathing for trillions of years. These are not science fiction scenarios. They are the genuine practical problems that the 99.7% detection has forced into our reality. This crisis is deepened by the law vault possibility that K2-18b is a single integrated sentient sphere. If the entire planet is a biologically integrated entity, do we have the right to disturb a trillion-year stability for the sake of our curiosity? On Earth, we struggle to protect a single forest or a single species. On K2-18b, we are facing an organism that has achieved a living equilibrium that has endured since before our solar system was even formed. The decisions made by the first generation after this confirmation will establish precedents that are extraordinarily difficult to revise. Moving too fast, treating a living world as a resource, or failing to establish a protective framework before the technology for contact exists could have consequences that last longer than any political cycle in human history. Yet while the lawyers and philosophers argue, a quiet revolution is already occurring in the minds of our children. The children growing up in the wake of the James Webb discovery will be the first generation in 300,000 years for whom the existence of life beyond Earth is not a question, but a fact. To them, the Tuesday silence is not a memory. It is the basic factual landscape of their existence. They will not look at the night sky as a vast, silent mystery populated by unreachable points of light. They will see it as a populated landscape, an archipelago of possible worlds, each carrying its own weather, its own chemistry, and its own version of survival. The question that defined every human ancestor, "Are we alone?" will simply fade out of their vocabulary. It will be replaced by questions that are far more interesting and far more difficult. What kind of neighbours will we be? What are our obligations to worlds we can hear but never touch? This shift in perspective is the ultimate challenge to our identity. We are used to being the only aware part of the universe, the self-appointed stewards of life. But the 99.7% is telling us that we are just one node in a network of living worlds, some of which are likely older and more complex than we can imagine. We are not the authors of the story of life. We are a single chapter that has just realised it is part of a much larger book. The silence of the galaxy wasn't a sign of our uniqueness. It was a reflection of our inability to listen. Now that we have finally developed the precision to hear a neighbour breathing 120 light years away, we must reckon with the fact that we were never the centre of the story. The crisis of contact is, at its heart, a crisis of maturity. It is the universe asking us if we are ready to join a conversation that has been happening for billions of years. It is a demand that we evolve our ethics, our laws, and our philosophy at the same rate that we evolve our telescopes. K2-18b has given us the evidence. Now we must find the wisdom to handle it. We are standing at the threshold of galactic citizenship, and the 99.7% signal is the bell that has been rung, announcing that the time of our cosmic isolation is over. The stars are no longer just light, they are addresses. The darkness is no longer empty, it is breathing. And as we look into that red sun 120 light years away, we are forced to admit that the greatest mystery isn't what is happening on that world. It's what we are going to do now that we know it's there. What we are witnessing is not merely a discovery, but a cosmic awakening. For 300,000 years, the human species has functioned like a mind in a sensory deprivation tank, dreaming of others but hearing only its own thoughts. We built myths, religions, and philosophies to fill the void, always operating under the unexamined assumption that the darkness between the stars was a sterile graveyard. But the James Webb Space Telescope has changed the fundamental character of the night sky. In the moment its detectors registered the filtered starlight of K2-18b, the universe achieved something it had never managed in 13.8 billion years: self-awareness at a distance. We have reached a point where the universe is using an instrument of its own construction, us, to look into a mirror placed 120 light years away and recognise its own reflection. The Tuesday silence at Cambridge was the last moment of our species' technological infancy. What follows is our difficult, necessary entry into galactic citizenship. The 99.7% confidence level is the threshold of this recognition. It is not just a statistic produced by an algorithm. It is the point where the weight of evidence becomes so heavy that it crushes our old delusions of being a biological miracle. We have spent our history believing that life was a 1 in a billion accident, a fragile flame that only happened to catch on this one specific rock. But the law vault suggests a deeper, more unsettling reality. Life is not a miracle, it is a law of physics. It is what the universe does whenever it is given enough time and the right toolkit. The 99.7% is the statistical proof that we have run out of excuses to be alone. When we look at K2-18b, we are seeing the biological probability variable of the Drake equation finally anchored to reality. We have found that the fraction of habitable worlds that become living worlds is not zero, it is, in fact, remarkably high. This discovery retires the oldest question in science, are we alone? And replaces it with the only question that truly matters, how often does this happen? The answer suggested by the law vault and the Webb data is that the galaxy is not a desert, but a dense, ancient and teeming forest. We have been standing in this forest for our entire history, but we lack the golden eye necessary to see that the trees around us were breathing. K2-18b is the first tree we have been quiet enough to hear, but it will not be the last. The instruments we are building now, the Nancy Grace Roman Telescope, the Ariel mission, and the extremely large telescope, are designed to transform this singular discovery into a comprehensive catalogue. We are moving from the era of finding to the era of statistics, where the existence of a living world will be as unremarkable as the existence of a red dwarf star. We are about to witness the demotion of life from the category of exceptional to the category of ordinary. This is our third great demotion, first from the centre of the solar system, then from a position above nature, and now from the belief that we are a singular occurrence in a silent void. However, the law vault mystery of the planetary organism forces us to confront a version of life that is fundamentally more mature than our own. We have been looking for aliens that look like us, technological, expansionist and noisy, but K2-18b suggests a sentient sphere, a world where the biosphere has reached a state of trillion-year stability that we can barely conceive, while we are an adolescent species currently dismantling the self-regulating capacity of our own home. K2-18b is an empirical model of a biosphere that has achieved a settled, self-correcting balance. It has weathered the storms of its red dwarf star and the fluctuations of its elliptical orbit for billions of years, longer than we have existed. This is the mirror in the dark. We have used our greatest technology to find a world that is 99.7% alive, only to realise that it is a world that has mastered the one thing we have not: duration. This realisation creates a profound shift in how we perceive our own value. We are no longer precious because we are a miracle. We are precious because we are one local expression of a universal process. We are the universe's way of knowing itself. The fact that life can take root in the hydrogen-rich atmosphere of a sub-Neptune world, orbiting a dim red star, proves that biology is robust, resilient, and virtually inevitable. The 99.7% is the probability that we are part of a neighbourhood of living worlds, each carrying its own weather, its own chemistry, and its own version of survival. The night sky is no longer a graveyard of unreachable lights. It is an archipelago of possibilities. Every child born after this moment will grow up in a universe that is no longer empty, looking at the stars as addresses rather than symbols. The law vault identifies the 99.7% figure as more than just a number. It is a cultural artifact of hope. It represents our collective need for a precise certainty to bridge the gap between scientific observation and existential belief. Even as we wrestle with the remaining 0.3% of doubt, we must recognize that the silence of the cosmos has been broken forever. The stars were never silent. They were speaking in the language of transmission spectroscopy and chemical barcodes, and we simply had not yet learned to hear. K2-18b has given us the first faint reply, the sound of something alive going about its existence 120 light years away. It is not a roar or a broadcast. It is a quiet ancient heartbeat that has been thumping in the dark for eons. As we conclude this exploration, we must accept the burden of what we have found. We are now the witnesses to a living universe. The confirmation of life on K2-18b makes everything we have built to govern our behaviour, our laws, our ethics, and our philosophies catastrophically insufficient. We have detected the breath of a neighbour, and in doing so, we have entered a new era where we can no longer treat the cosmos as an empty room to be explored without restraint. We must find the wisdom to handle this evidence. We have crossed the threshold from cosmic isolation to galactic citizenship. The 99.7% is the bell that has been rung, announcing that the silence is over. The universe is alive, it is breathing, and we are finally, for the first time, home. The final answer to the oldest question isn't found in a radio signal or a photograph, but in the barcode of starlight we caught on a Tuesday morning. We are not alone. We never were. We were just late to the conversation, and now that we have learned how to listen, we realise the stars have been full of something breathing all along. The James Webb Space Telescope has given us the first page of a much larger map, and as we begin to fill in the living biospheres of our neighbourhood, we realise that the universe is not an empty cathedral, but a teeming, fertile and patient forest. K2-18b was just the first whisper. The roar of the living cosmos is about to begin.